We covered intelligent calculation. Now let's talk about something equally important but often overlooked. That is how to organize your calculation scripts and manage the development process from prototype to production. Writing a script that works is one thing. Writing a script that maintainable, testable and production ready is another. Many developers spend all their time learning fixed statements, if conditions, and writing business rules. But in production environment, most calculation issues don't occur because of syntax errors. They happen because scripts were not properly tested, validated, documented, or deployed. So in this video, we will walk through a practical development framework that can be applied to a traditional business rule or groovy rules, allocations and forecast calculation in EPBCS hybrid BSO model. So we will cover 4 stages. One is prototype, second one is the pilot, third is a test cycle, and then deploy. Let's deep dive in each category. So first let's go to the prototype. The first stage is prototype. The objective of prototype stage is simple. Validate the business logic before testing against a large volumes of data. So what we used to do in on-premise Essbase environment is developers often used separate test databases. In EPBCS, a more practical approach is to use a dedicated test environment or a limited planning slice. For example, suppose there is a business requirement to calculate a margin. So the formula is revenue minus cost. So our calculation might look like this. So fix of whatever is required, and the logic is margin equals revenue minus cost. Before running this rule across thousands of entities and products, we can test to a small sample. For example, we can test if we input a revenue, cost and margin for a single combination. The result matches. So after running the rule, we need to make sure that the result matches as expected, that is 40, right? That is 100 minus 60. My margin should be 40. So at this point, we are not testing the performance. This is an important point. We are not testing the performance. We are making sure the result matches as per the business requirement. So we are simply proving the logic is correct. So a common mistake during prototyping is using a large data set too early. So when a calculation fails across millions of intersections, troubleshooting becomes very difficult. So it's always better to start with a small portion or a slice of data. So let's take another bit complex example for the prototype. Suppose management wants a corporate expense allocated based on the revenue contribution. Assume that we have inputted data for a particular combination, that is corporate expenses 1000 and revenue by entity. So my East Mine revenue is 60,000 and West Mine revenue is 40,000. Total revenue will be 100,000. So what will be the allocation percentage? 60,000 out of 100k is 60% and 40% for West Mine, and expected allocation will be 600 and 400. So before writing a production allocation, manually calculate the expected result. Then verify the rule produces the identical value. So this simple validation step prevents countless production issues. Next is the pilot testing. As you can see, the second step is pilot testing. Once the prototype works, move to pilot testing. Pilot testing introduces a real world data while limiting to a business impact. Instead of processing the entire application, we can select a controlled subset. For example, we can select a scenario called working, version final, or scenario can be actual, version final, entity, fix the entity as East Mine. Instead of running for all the entity at once, we can take a subset of the data and period Jan through March instead of Jan through December. So now we will test against the actual application data with a sample slice combination. So why is this important? This is important because production data always contains surprises. For example, it may have the missing values, unexpected member combinations, new entities, inactive products, or shared members or alternate hierarchies. So the prototype may have worked perfectly because all inputs were clean and it was manually inputted for us to check the prototype whether it's working fine or not. So pilot testing reveals problems that only appear in realistic conditions. So let's consider a hybrid specific scenario. Suppose product hierarchy contains a product, crushers, conveys, and screens. So there are different products. So during prototyping, we would have input data for only one product and done the testing for only one prototype. So that rule may work perfectly. So during pilot testing, the business loads the data for other products as well. So suddenly calculation produces unexpected results because those members were not included in the fixed statement. So pilot testing exposes these gaps before deployment. So this is the reason pilot testing is so valuable. So the third stage is the test cycle. This stage answers an important question. Did the new calculation change result unexpectedly? Whenever modifying an existing calculation, we need to compare the new output against the baseline, right? So let's take an example. This is the current production rule, that is bonus equals revenue into 8%. This is a standard calculation which was present in the production. Now we get a new requirement from business asking that if revenue is greater than 60k, then bonus should calculate revenue into 10%, or else it should follow the same old logic, that is bonus equals revenue into 8%. So how do we test this? First, we need to run both the versions, export the result after each version is executed. Then we need to compare the outputs. Suppose if entity A revenue is 50,000, the old bonus or the old logic shows 4,000 and new logic the bonus shows 4,000. So there is no change because our condition is only if revenue is greater than 60k. Since it is not greater than 60k, my bonus value should remain same as per the old logic. When it comes to entity revenue B revenue, 80k is the revenue value. So old bonus still shows 6,400, and as per new logic, the new bonus will be 8,000, which is the expected difference. Similarly, when we compare entity C revenue, it is 30,000, which is less than 60k. Old bonus and new bonus will remain same and there is no change. So this is how the testing will be carried out. So this comparison helps identifying legitimate changes versus unexpected calculation errors. In case of hybrid specific testing, additional validation is also required. So we should also test dynamic calculations, shared members, alternate hierarchies. In alternate hierarchies, we need to ensure totals are consistent across reporting views, and data maps and smart pushes as well. Whereas in data maps and smart pushes, we need to validate the data movement between the cubes. Hybrid introduces dependencies that do not exist in traditional BSO. So testing these areas is very essential. So the last step is deploy. After successful testing comes the deployment. Before deployment, every change should be documented. At minimum record, that is rule name, version number, developer name and the date, what is a business requirement, and if there is any approval required, then we need to include that approval details as well. So this is the simple documentation header. It might look like this. That is, if we are performing a revenue calculation, we need to give the rule name and which version is it, who's the author or the developer, on which date we are deploying, and what is the purpose or the business requirement. So this is the basic documentation which needs to be done before we start writing the script. So why this is important? Because 6 months later, this information becomes invaluable during troubleshooting. At least the developers will understand what is the purpose of this business rule, and it will be easy for the developer to troubleshoot. And another main important thing is the version control. So one of the most overlooked practice in EPBCS development is version control. We should never rely on the roles stored inside the application as your only master copy. So maintain a repository containing the business rule. It can be a Groovy role, metadata file, REST API scripts, EPM automate script, maybe migration artifacts. Many organizations use some kind of repository tool to save the versions. Even a structured folder, if there is no repository tool, we can maintain a structured folder system, which is better than having no version history at all, right? So we can maintain a folder with a timestamp. So when a production issue occurs, you can quickly identify what got changed and what got impacted. Then organizing the calculation logic. So as application grows, calculation script becomes difficult to maintain. So we need to avoid creating one massive rule that performs every process. So instead, we can separate the logics by business function. For example, rule 1 we can create for forecast seeding. For rule 2 we can execute a driver calculations, rule 3 for allocations, rule 4 for reporting adjustments, and rule 5 for consolidation logic. We can write or include all this logic in one rule, but it will be a big chunk of script which will be very difficult for us to troubleshoot in the future. So this modular approach offers several benefits, like easier to debug, easier for testing, faster deployments, and improved maintainability. So if allocation issue occurs, you only investigate allocation logic rather than searching through thousands of lines of code. Now let's understand what are all the common mistakes the developers do. Testing only happy path scenarios. Developers test clean data and standard member combinations. So production environment may contain missing values, new entities, new products, and unexpected intersections. So always we need to test the edge cases instead of testing the clean data. So this means we need to do a positive and negative scenario testing and make sure we cover all the exceptions. And the second mistake is ignoring hybrid specific behavior, because we need to validate the dynamic calculations, solve orders, alternate hierarchy, shared members. So all this are very frequently causes the unexpected result. And the last mistake is no rollback plan. So before deploying changes to the production, we need to export the current rule, create application snapshot, store migration artifacts, and keep the previous version available. In case if something goes wrong post deployment, rollback should take minutes, not hours together, right? So successful EPBCS development is not just about writing calculation. It's about following a disciplined development process. So we need to start with the prototype by validating the business logic using simple controlled examples, then move to a pilot testing, test realistic data and identify the edge cases, perform a formal test cycle, by comparing new result against the trusted baseline, and finally deploy. So document changes, maintain version control, and prepare a rollback strategy. So following this life cycle dramatically reduces the production issues and makes your application easier to support and maintain over time. Thank you for watching, and I will see you in the next session.